Hey everyone, welcome back to Tech Adventure. Continuing our journey into the field of embedded development, today's focus is on the significance of electronics and hardware skills. Join us as we explore their crucial role in shaping the landscape of embedded systems. If you missed our previous video where we covered the essential skills for embedded developers and programming languages, I highly recommend checking it out first. We'll break down complex concepts into easy-to-understand bites, covering everything from basic electronic skills to microcontrollers and more. Get ready to learn and explore as we lay the foundation for your electronics and hardware skills journey. Let's dive in. Knowledge of basic electronics. To excel as an embedded developer, it's crucial to have a solid understanding of electronics, digital systems, and microcontroller architecture. Start by learning the fundamentals of electronics, including basic circuit analysis, digital logic, and microcontroller principles. Dive into topics such as voltage, current, resistance, Ohm's law, and basic electronic components like resistors, capacitors, and diodes. As you progress, familiarize yourself with more advanced concepts such as microcontroller architecture, memory types, input-output, I/O, ports, timers, interrupts, and peripheral interfaces. Understanding these concepts will help you comprehend how embedded systems interact with hardware components and peripherals. Additionally, learn how to read and interpret schematics, which are diagrams that represent the electrical connections and components within a system. Schematics are essential for understanding the hardware layout of embedded systems and troubleshooting electronic circuits. Lastly, become proficient in reading datasheets, which provide detailed information about electronic components, microcontrollers, sensors, and other hardware devices. Datasheets contain specifications, pinouts, electrical characteristics, timing diagrams, and application notes, which are invaluable resources for designing and programming embedded systems. If you're enjoying the video, please consider giving it a thumbs up and subscribing to our channel. Don't forget to hit the notification bell to stay updated on all our future videos. We value your input, so feel free to share your suggestions for topics you'd like to see covered in the comments section below. Hands-on experience. Gain practical experience by working with development boards, microcontrollers, and sensors. Start by experimenting with beginner-friendly platforms such as Arduino or Raspberry Pi, which provide a user-friendly environment for prototyping and learning embedded development. Begin by blinking LEDs, reading digital and analog inputs, and controlling various output devices. As you become more comfortable, explore more complex projects involving sensor interfacing, motor control, communication protocols, and data acquisition. Experiment with different microcontroller families and development environments to broaden your skills and knowledge. Become proficient in using development tools such as integrated development environments, IDEs, compilers, debuggers, and programmers. Engage in projects that align with your interests and career goals, whether it's building a home automation system, designing a robotic vehicle, or developing an IoT device. Hands-on experience will reinforce your theoretical knowledge and help you develop problem-solving skills essential for real-world embedded development challenges. Now that we've covered the essential electronics and hardware skills for aspiring embedded developers, let's explore some crucial architecture and design principles. We'll delve into microcontrollers, microprocessors, memory management, and peripheral interfaces to deepen our understanding of embedded systems hardware skills. Microcontrollers. These are integrated circuits that contain a processor core, memory, both RAM and ROM, and various peripherals like timers, counters, analog-to-digital converters, ADCs, and communication interfaces, UART, SPI, I2C, all on a single chip. Microcontrollers are commonly used in embedded systems due to their compactness, low power consumption, and cost-effectiveness. They are ideal for applications requiring real-time control and handling of input-output operations. Microprocessors. These are central processing units, CPUs, designed for general-purpose computing tasks. Unlike microcontrollers, microprocessors do not typically include on-chip memory or peripheral interfaces. Instead, they rely on external components such as memory chips, I/O controllers, and communication modules to function. Microprocessors are commonly used in more complex embedded systems that require higher computational power, multitasking capabilities, and connectivity options. Memory management. Memory management in embedded systems involves the efficient allocation and utilization of various types of memory resources, including RAM, ROM, and non-volatile memory, example, EEPROM, flash memory. RAM, random access memory, is used for temporary storage of data and program instructions during runtime. It is volatile, meaning its contents are lost when power is turned off. ROM, read-only memory, stores firmware, bootloader code, and other essential software components that are not intended to be modified during normal operation. ROM can be further classified into different types, such as PROM, programmable ROM, EPROM, erasable PROM, and EEPROM, electrically erasable PROM. Non-volatile memory, such as EEPROM and flash memory, retains data even when power is removed. It is often used for storing configuration parameters, calibration data, and firmware updates. Efficient memory management is critical in embedded systems to optimize performance, minimize memory footprint, and ensure reliable operation. If you're enjoying the video, please consider giving it a thumbs up and subscribing to our channel. We value your input, so feel free to share your suggestions for topics you'd like to see covered in the comments section below. Peripheral interfaces. Peripheral interfaces facilitate communication between the embedded system and external devices, such as sensors, actuators, displays, and communication modules. Common peripheral interfaces include GPIO, General Purpose Input-Output, pins, UART, Universal Asynchronous Receiver Transmitter, SPI, Serial Peripheral Interface, I2C, Inter-Integrated Circuit, CAN, Controller Area Network, USB, Universal Serial Bus, Ethernet, and more. Each peripheral interface has its own protocol, communication speed, data format, and electrical characteristics. Understanding how to configure and interface with these peripherals is essential for developing embedded systems that interact with the external world effectively. Peripheral interfaces enable embedded systems to gather sensor data, control actuators, display information, communicate with other devices, and interact with the user, making them integral components of embedded systems architecture. Day by day, we are reaching to our goal of becoming masters in embedded systems, and we will keep continuing. I hope you liked the video. Thank you for joining us on this journey through electronics and hardware fundamentals. We hope you've gained valuable insights and feel more confident in your understanding. Remember, learning is a continuous process, so keep exploring and experimenting. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell to stay updated on our latest content. Until next time, happy learning.